So one of the things that you're going to have to know how to do for the AP test is that they have you do rectangular approximation or Riemann sums using a table. Okay, so we're going to practice finding area with a table of values. Okay, so basically we're doing we've got a function, right? They're giving me x values and y values. They want us to estimate the area under this curve using left-handed rectangular approximation with 6 intervals. Okay, so basically these are my rectangles. I have one from here to here, I have one from here to here, one from here to here, like this. Okay, this is rectangle 1, 2, 3, 4, 5, and 6. Okay, so I'm going to graph it, these coordinates, just so that you could kind of see what it looks like. So this is 5, this is 10. So -1, 7, point right here, and 0, 5, right there, 2, 6, right there, 4, 8, so that puts it right there, 7, 7, and then 6, and then 9, 10, and then 13, 13, 0. Okay, so we're going to be using this data, so we got to create our rectangles. So my first rectangle is between -1 and 0. Okay, now we're using LRAM, which means this rectangle gets its height from where the function is on the left side. So we go up the left side of it. Once we hit this, that is our rectangle. Okay, so our next rectangle is from 0 to 2. And we go to the left side and we go up, hits here. So this is the height of my rectangle. Okay, then we have from 2 to 4. This is another rectangle. So on the left side we go up, we hit there. So that's my area. Then 4 to 7. So here, like this. There's my rectangle. From 7, go up to here, like that. And the last one from here, like that. So these are my rectangles. These are my areas I need. Okay, so rectangle 1. Okay, the height, these are all going to be basically the height times the width. Okay, so the height comes from the left side, which is 7. This one. Okay, the width is from here to here, the x value. So that is a distance of 1. So this is 7 times 1. Then we have rectangle 2. The height comes from the left side, so 5 times the width from here to here. This is a width of 2. Rectangle 3. The height is 6. The width is 2. 2. And this one, 3, 2, and 4. So rectangle 4 is 8 times 3. Rectangle 5 is 6 times 2. And rectangle 6 equals 10 times 4. Okay? So the difference between what we've been doing though is here all of the widths are not the same. So my total area is going to be rectangle 1 plus rectangle 2 plus rectangle 3, rectangle 4 plus rectangle 5 plus rectangle 6. So R1, this is 7 plus 10 plus 12 plus 24 plus 12 plus 40, which gives us our total area of 105. And that is the area, approximate area. Okay? And if you drew in your function, it would look something like this, because it's, and you can see that this is probably a gross overestimation. Okay, but that's how you do it. Now, if it had said to use RRAM, so that's the other question I get. So if it had said to use RRAM with the same data, okay, that just means my rectangle 1, we would have used 5 first. So this R1 would have been the 5 times 1. And then rectangle 2, since it's using 6, would be 6 times 2. On the graph, if you looked at it, it would have been like this. This is what it would look like if you did right hand. Right hand would look like this. Okay, the rectangles would get its height from the right side of my interval. Okay, so just make sure that when you're doing these, that you're following the rules for the rectangular approximation, whatever you're doing, left side, right side, or midpoint.